Good morning, good afternoon, or good evening. Welcome back to the channel. I hope you're all doing fantastic. If you're watching this, you're obviously interested in Cisco's Catalyst SD-WAN, and you've come to the right place. This video is part of a larger SD-WAN series, and it's focused on device templates and feature templates. So I'll be using a single router inside of a branch location to demonstrate some common use cases with templates. So with all that being said, let me go ahead and share my screen. And let's take a peek at the topology. Essentially, for the sake of this video, we're going to be focused on the bottom two rectangles, if you will. So San Jose, California is a campus that is running the 10300/16 subnet. We can see it's going to be site 3, or it is site 3. And then on the bottom right, we see Research Triangle Park, which is going to be running 10400/16. It is going to be configured for site 4. And there's an edge router at each of these locations that has a Gig 1 and Gig 2 interface that is connected to MPLS and Biz Internet, respectively. There's a Gig 4 interface that is a downstream link to a switch. In this case, it's a Catalyst 9kV in each location. That link is going to be configured as a trunk port, which will allow us to run sub interfaces on the router, which is nothing more than router on a stick. Those sub interfaces will be VPNs that run on the overlay of the SD-WAN fabric. So we'll configure those templates together. Those VPNs will be broken out in the form of VLANs on the switch, respectively VLAN 10 and 20, as we can see depicted here. And PC1 in each location will participate in VLAN 10, and PC2 will participate in VLAN 20. We'll do some connectivity tests and see what differences in behavior or what behavioral characteristics we see after we push the templates. Let's hop over to Manager. We can see that the two devices have been onboarded into the SD-WAN fabric, but that's it. There's no configuration on those devices. We're going to be doing that together. Just to kind of show from the command line perspective, if I show IP interface brief, the only thing we see is the internet IP address, which was needed to get the device onboarded into the fabric. That's it. We don't see sub interfaces on 04. We don't see the MPLS interface. We don't see any of that configured yet, like I described. We're going to be doing that together. The switch, however, is pre-configured, and the PC should have an IP address on the respective VLANs for the sake of time. So that way we can focus on the template creation and push. So let's head over on Manager. If we go to Configuration, Classic, and then go to Templates, there's the concept of device templates and there's the concept of feature templates. And you can see that there are none defined in the fabric yet. So we're going to go ahead and we're going to create all that stuff together. So feature templates, we're going to add a handful of feature templates, maybe 2 handfuls, if you will, that we're going to essentially then attach to a single device template. And that single device template will be reused on the 2 routers in the topology. So the purpose of the demonstration is to show you how we can take multiple feature templates, throw them into one device template, and then share that device template out to as many devices as we need to. It's for scale. If you have 1,000 devices in your fabric, you can use one device template to essentially push all the features to all 1,000 devices. In our case, we're going to be using 2 devices, but it will be an N+1 concept. So let's go ahead and create our first feature template. So we're going to add template, and we're going to search for 8,000 because the routers that we're running are 8,000 Vs. So let's go ahead and create a AAA template. And this is just going to be used for the username and password of the box. So we're going to give it a name first and foremost. We'll call it branch AAA. And you can see that the username is in fact there. All I'm going to do is just go ahead and type out the password that I want. just to make sure that it's there. And I'm going to leave it as privilege level 15. I'm going to go ahead and just save that. And I'm going to scroll all the way down to authentication and authorization. And I want to be sure to set that to local. So essentially that's login local from a CLI perspective. I want to use the local database for the login. Now, if you were running this in a production environment, this is where you would want to define your TACAC servers or your Radius servers, for the authentication types that you want to run. Since this is a lab, I'm just keeping it stupid simple, and I'm using a local login. So I saved that template. Let's go ahead and add another template. This time we are going to add a Cisco system template. So every time you click in it, for whatever reason, it scrolls down the bottom. You got to scroll back up. So I'm going to call this branch system. And this is where we're going to get into more of the device specific kind of parameters, if you will. So the first option we have is site ID. So if I click this little drop down, I can change it to global, and then anything I type here would basically get applied to any of the devices that we attach to the template. Obviously, I don't want that to be the case because not all my routers are going to be in the same site. I want to be able to specify that on a per device level. So we obviously we pick device specific here, and I'm just going to add site ID in all caps. Now this key is important. This is like a variable or a descriptive key. So when we go to attach the devices later on, about 20 minutes from now, it's going to prompt us to enter or fill out the information that we want to populate onto the configuration of the router. And if we don't make this verbose enough, we won't know what value we're supposed to be entering. It'll make more sense when we get to that point, but make this as descriptive as you can or unique enough to distinguish between the various templates. So for system IP, we're going to also make that a device specific, and I'm just going to put in all caps system IP. Host name, that's obviously something that's going to be unique on a per device level. So I'm going to just say host name in all caps. For the baud rate, I'm going to globally set this at 9600. This shouldn't really matter in my environment because it's irrelevant. For maximum OMP sessions, I'm actually going to globally hard code this to be 2. Transport gateway is a setting that if you were running this in production, you might want to toggle, you might want to set this to device specific and allow, be able to turn it on or off as you see fit, because depending on whether the router is a head end or a branch, you might want to, you should most likely change that according to the placement of the router. Just again, this is a lab. I'm not going to worry about that right now. This is more template driven example. Same thing goes with port hopping. That's something that you would want. A lot of these settings, you're obviously going to want to potentially change in a production environment, but for the sake of a lab, they're fine. Let's go ahead and add another template. So we're going to add, so at this point, we need to start considering the underlay interfaces in our topology, right? So if we go back, we know that the branch routers are going to have gig 1, 2, and 4 are in play. So if we make our WAN cookie cutter and every single branch site has the same interfaces that are going to be reused for either LAN, biz internet, or MPLS, we want to make sure that our template takes that into consideration. So let's go ahead and address that now. So we're going to go ahead and we're going to add a VPN interface Ethernet, as it's called. So let's scroll up. Let's give it a name. And I'm going to call it G1. So essentially all I'm doing is this is going to be the IP address and subnet information that is going to be assigned to gigabit Ethernet 1. That's all this is, right? So I want to globally say no shutdown. I want that interface to be enabled. For the interface name, I'm going to globally set this to be gig Ethernet 1 because, again, the WAN is going to be cookie cutter in this particular example. Now for the IP address, this is obviously going to change on a per box basis, right? So I want to make this a device specific variable, and I'm going to say gig 1 IP and mask. Again, this is what it's going to present me when I need to fill out the values. So that's verbose enough to know that I know this is the gig 1 interface IP address information. So this is going to be a tunnel interface because it needs to serve the overlay. So I'm going to globally set that to be on. Now we're presented with some additional options now that it's a tunnel interface. For the color, again, based on our topology, gig 1 is always going to be connected to the MPLS. So again, we go back to the topology, gig 1 is always MPLS. So we're just going to hard code that to be color MPLS. For max control connections, I'm actually just going to set this to 0. And then all these other options are not pertinent to this particular lab because again, we're just keeping it very basic. So we're going to save that. Now, since we have this defined, we can go ahead and copy this and we can reuse this for gig 2. So we're going to change the name to be gig 2. Now that it's copied, we're going to just edit the values that matter. So we go in, scrolling up. Obviously the interface is gig 2, so we're going to change that. For the key for device specific, for the IP address, I'm just going to change it from G1 to G2. Scrolling down, it's still a tunnel interface, but in this case, it's going to get the color biz internet. And for this one, I'm going to make the max control connections 2. I explained that in a previous video, so hopefully you saw that, but that's what that value is pertaining to. So I'm going to go ahead and update that. Now we need to do another interface, which is gig 4. Now gig 4's more of a parent interface. Okay, so it's going to be a bit different, but we can still go ahead. Let's just copy gig 2. Let's change it to gig 4. And let's edit the values in G4. Scrolling up. All we need to do for this particular template is basically just no shut the interface. Again, because this is going to be a parent interface, we're going to define sub interface templates in a minute here, which will attach to gig 4. So only thing we need to do is just no shut it. It's gig 4. For the IP address, since it's the parent interface, we're just going to change this to default. It is not a tunnel interface. And that should be it. So we're going to hit update. All right. So now we have to define the VPNs. So let's go ahead and add VPN 0. So we scroll down to the VPN section and we select Cisco VPN. Scrolling up, we'll give it a name. We'll say branch VPN 0. Obviously, the VPN number should be 0. For DNS, I'm actually going to globally set this to be my domain controller that I'm running in my environment. And for the route, I'm actually going to throw a default route in there. based on the topology. The biz internet is how what we're using to get VPN 0 up and running. So that's all we're going to do is set all the same routes to be this address, the next hop. So we'll add that. And that should be enough for VPN 0. So what I mean by that, if I go back to the topology, all these boxes that have a link to the biz internet, they connect to this unmanaged switch in this particular, in my lab topology, I'm just using an unmanaged switch. So in theory, all these boxes sit on the same subnet broadcast domain, if you will, which is the 172.16.11. So I'm pointing them all to the same next hop, essentially. That's all that I did. So that was VPN 0. So let's go ahead and create VPN 10 and 20. Scrolling up, let's give it a name. Branch VPN 10. The VPN is obviously 10. And everything else in here, we are just going to leave at default. Now we can copy that one and basically change it to be 20. Okay, after we copy it, we just go in and we change the VLAN identifier from 10 to 20. All right, scroll up, change that to 20. Should be the only change we need to make. So let's go ahead and update that. All right, and then the last two templates we need to create are for the sub interfaces for VPN 10 or VLAN 10 and VLAN 20. So let's go ahead and create those. So that's going to be VPN interface. So we'll call that branch VPN 10 IP and mask. Excuse me. All right, so we want to globally no shut that. Now the interface name, since it's not going to change, we're going to hard code this as a global variable. And the sub interface is going to hang off gigabit 4. And in this case, it's VPN 10, so it's going to be .10. For the IP address, we're obviously going to want to change the sub interface IP on a per box basis. So this should say something like gig 4.10 IP and mask. All right, I'm going to save that. And then I'm going to copy that. And I'm going to tweak it for 20. Go in, edit the variables. So 4.20. And then for the IP address, we want to make sure that we prompt ourselves with 20 instead of 10. Let's go ahead and update that. All right. Now that we've got our feature templates, let me do one more. because in the event that I need to reboot the router, there is a, where is it? CLI add-on, branch CLI. And all I'm going to do here is platform console serial, and I'm going to save that. So it's just a function of the lab. If I reboot the box and the routers are in controller mode, it won't prompt me with the serial, you can't access the router basically. Okay, so now what we need to do next is, now that we have our feature templates defined, we need to create the device template that we're going to reference all those feature templates that we just made. So we go to device templates, we create a template from feature template. It wants to know the model of the box, in this case C8000V. It then asks us what's the role. In our case, it's an SD-WAN edge. We'll give it a name. We'll say branch single router. And now all we need to do is reference all of the various feature templates that we create. So for Cisco system, we're going to go ahead and pick the one that we created, which is branch system. Scrolling down for AAA, we're going to select the one that we created. So under transport and management, for VPN 0, we're going to select the VPN 0 that we made. Now for the interfaces, this is where we're going to reference G1, 2, and 4. So we're going to say 1. Now we need to add additional. So it says additional templates. We're going to create 2 more of that type, which is VPN interface. And we're just going to select G2 and G4. All right, scrolling down for service VPN, this is where we want to add our 10 and 20. So we're going to say add VPN. And we're going to select 10 and 20 that we created. We're going to move them over and we're going to say next. I'm going to hit add. And then one at a time, I'm going to edit them. So I'm going to go into 10 and I'm going to add the interface Ethernet, and I'm going to reference the VPN 10 IP and mask template that we made. Same thing for 20. I'm going to add that as well. Only difference being this one's going to be obviously 20. Save that. Scrolling down, the last one is the CLI. That's that platform console serial command. So we'll go ahead and attach that. So let's create that. So now we have a device template that we just created together that references all the feature templates that we made 10, 20 minutes ago. Now you can see there's no devices attached. It's 0. So that's what we need to do. We need to attach devices to this template now. So if we click and say attach devices, if we scroll down, we can see that here's our 2 branch sites. So we're going to start with San Jose. We're going to basically put San Jose, attach San Jose to this template. And it brings up a workflow. Now the workflow has an X here. If you expand this, it says status has an X next to it. It's not happy about something. It's because we didn't fill out the variables. So we need to click edit device template. And what we need to do is we need to tell it what those values are supposed to be. Now in parentheses, this is the descriptive keys that I was stressing, that you have to make sure that you give it something, descriptive enough to know what you're putting in. Because if you didn't do that, you're just going to get basically this generic message, and you're going to have the wrong IP assigned to the wrong interface. So in this case, it's gig 4 VLAN 20. So we know that the site is 10.3. So 10.3.20 for VLAN 20.1/24. For VLAN 10, we're going to do 10.3.10.1. 24. For gig 2, the IP and mask, we can go back to our topology. For gig 2, we know that that's going to be the 172.16.11.network. So since this is site 3, I'm just going to use 103 as the last octet because it's easy to remember. /24. Same thing for gig 1, that's the MPLS. So we know the MPLS is 192.168.11. So I'm just going to make it 103. All right. Host name is obviously SJC CE01. System IP is 10.3.0.1, and the site ID should be 3. Right, site 3. So now that we've filled out all the values, let's hit update. Now we can see we have a green status check mark saying that, okay, the workflow seems happier now that we gave it values. So we're going to say next. And at this point, we should just have to hit configure devices. And I'm going to bring up the console of SJC. We can see in the background the status has changed to in progress, and we can see a whole bunch of status messages coming across the router, which is a good sign. It's being configured. Okay, so in the background, we can see that the status has gone to success. So I'm going to go ahead and full screen the router at this point. And what we should see, hopefully, is if I do a show IP interface brief. So this is good, right? So now we can see Gigabit Ethernet 1 now has the MPLS address that we told it it's supposed to have. We also see that Gigabit Ethernet 4 has become a parent interface, and it now has sub-interfaces below it, respectively 10 and 20, which are our 2 VPNs. So this looks good. If we show IP route, in the global routing table, all we see is our underlay networks. So we see the MPLS and we see the internet, and then we have that default route that we put in VPN 0. We configure that together. The question is, where are the 10.3 routes that we configure? Well, the way SD-WAN works is it puts those in VRFs. So if we show VRF, we can see we have a VRF 10 and a VRF 20. And we also see that 10 and 20, the interfaces are now, the VRF is now participating on those interfaces. So if I do show IP route VRF 10, what I see here is the connected subnet of 10.3.10. Likewise, if I hit the up arrow and I do a show IP route for VRF 20, I see the 10.3.20. So now we know where those routes have gone. They've gone into separate routing table instances on the box. Now, let's go back to Manager and let's attach that same template. Let's attach RTP. So we scroll down, we find RTP, and we add RTP. It launches the workflow. It's unhappy because we need to fill out the variables. We know this. So 10.4.20.1/24, 10.4.10.1/24. This is the internet, so that's 172.16.11.104 in this case. This is MPLS 192.11.104 in this case. Host name is RTP. System IP is 10.4.0.1, and the site ID is 4. Let's just double check. Topology says 10.4, site 4, and we're good. So let's go ahead and say update. We now have a green check mark under the status, which is promising. Let's hit next, and let's go ahead and configure RTP. Let's do the same thing. Let's bring up RTP console. We can see the status has changed to in progress. All right, we're getting a boatload of messages coming across, so that's hopefully a good thing.